The 4-meter-long, high-tensile steel alloy billet is automatically loaded into a linear ultrasonic test.
The subtle variances confirm this batch is optimized for the driveshaft process A.
Absolutely. The chemical assay report right here confirms the successful segregation.
This one is for forging, not turning. Check the specs on the panel.
Confirmed. Adjusting the furnace temperature now.
As the induction coil activates, a gentle, controlled warmth evenly distributes internal stresses. This controlled scaling technique is essential for successful, large-scale structural component manufacturing. The heavy-duty robotic unit quickly scans the steel alloy segments. This confirms the structural integrity. A high-precision honing tool is inserted into the bore. The tool oscillates and rotates, meticulously polishing the easily. The completed drive shaft is loaded by the robotic system. The chambered hermetically, preparing the component. The drive shaft is rapidly quenched using high-pressure inert gas, instantly cooling the alloy.
Under ultraviolet light, minute surface cracks glow bright green, revealing defects invisible to the naked eye.
A tiny, automated laser ablation tool vaporizes microscopic amounts of the dark metallic gray steel. The ruby-tipped probe gathers billions of data points, ensuring absolute accuracy.
As the drive shaft enters the vapor degreasing unit, it is exposed to non-aqueous solvents, ensuring the absolute surface purity paramount for the F-35B.
The completed is wrapped in specialized V-seal. The massive robotic arm loads the high-tensile steel billet into the furnace. As the armored door seals,
The temperature curve is perfectly homogeneous. We've reached the optimal window for plastic deformation.
Acknowledged. Initiating extraction sequence.
the 10,000-ton hydraulic press slams the upper die onto the glowing segment with immense force.
Temperature stabilizing at 300 Celsius.
Cooling curve is nominal.
Following the fine machining phase, a robotic arm equipped with a specialized rotary brush attachment meticulously deburrs. The 3-meter structural bulkhead is placed onto a granite surface plate and a large articulated CMM arm with a massive
Hydraulic lines secured. Pressure holding steady.
Sensors attached and calibrated. We are ready for the sequence start.
The stress load is at 95%.
Data confirms it's well within the elastic limit. Process B is validated.
Following the successful static load test, the 3-meter structural bulkhead is subjected to a repeat lift.
Make sure the forward tensioners are at 150 foot-pounds.
Confirmed. All green.
Alignment is perfect on all axes.
Confirmed. Proceeding with the sequence.
As the massive aircraft moves under its own power, it showcases the successful culmination of...
As the F-35B lifts off, the structural bulkhead manages immense forces. The extreme thrust places...
The F-35B Lightning II relies on its central 3-meter structural bulkhead to manage the significant static stress of weapon loading.
An F-35B Lightning II takes off into the twilight, relying on the structural integrity of the internal bulkhead to...
The component, the structural bulkhead, supports the entire airframe under cruise conditions, ensuring the integrity necessary for sustained long-range flight.
The landing gear is deployed and locked into position. The attachment points transmit the entire landing.